So thank you very much. We can start. I think I can't hear you. I don't know why, but if I can start, I will start. Thank you very much for being part of this presentation. My name is Jean-Noël Nikiema. I am an assistant professor at the Department of Management, Evaluation and Health Policy at University of Montreal School of Public Health. It is a great pleasure for me to present KOSonto, an ontology we built to describe knowledge organization system, but also their constituents and their referents. Before starting, I want to say that the paper we submit was co-authored by Fleur Mougin and Vianney Jouet from the University of Bordeaux, and also Stefan Schulz from the University of Graz. Before starting my presentation, I want to say that I do not have any specific conflict of interest to declare because I only have academic affiliation that I have listed at the beginning of this presentation. So, when we talk about knowledge organization system, we try to designate all the resources human can make to try to describe a domain knowledge. It is a very heterogeneous group, and this heterogeneity can easily be accessed when we talk, for example, about the domain of usage. If, for example, we try to talk about clinical domain, we can refer to SNOMED CT as a knowledge organization system to help us standardize the domain content. For biological or laboratory results domain, we can think about LOINC, and for medication and drug, we can think about ERICS-NORM, ATC, or OCRX. For epidemiological purpose, we can think about ICD-10, and perhaps in the near future, we will talk about ICD-11. But in addition to this difference and the number of resources we have in the biomedical domain, we have a difference of structure. And this difference of structure is very important because it is mainly led by different philosophy for the building and construction of knowledge organization systems. And despite these difference of heterogeneity and philosophy, these systems are used together to describe clinical data, to standardize them, and to integrate health information system to try to create some specific indicator of health, public health indices. And we need to use them together, and they seem to be a meaningful ontological category. But when I first started to use a overarching term like knowledge organization system to describe them, people do not like it because it was a very difficult task to try to find a term to describe it very clearly on a specific domain, to have a specific framework. And these frameworks are sometimes contradictory from one domain to another. So this is a review I got when I tried to use this overarching term to describe a knowledge organization system as a meaningful category. And the problem is, even if we understand the difficulty to see the philosophy beyond each framework, they are still used together. So we need to have some project in a cross-disciplinary sector. So we need to think to them in a consistent way. But when we start some different project, we see that the word we are using from one discipline to another are inconsistent because we have how to say that? Because we have sometimes the same term, the same definition, but we still do not designate the same thing. We have, for example, to designate knowledge organization system term like control vocabularies, dictionaries, thesauri, classification, and nowadays we have terminologies and ontologies. And still, if you are from one discipline to another, this term can have different meaning and designate different things. And that also concerns the content of this knowledge organization system, and terms like concept, entity, relation, predicate are still very difficult to understand when we are going from one discipline to another. And MIVOC was a first attempt to try to to give us some consistency in the word and term we are using in the biomedical informatics. But we do not have a lot of takeaway from MIVOD. And since then, we have a lot of contribution from different disciplines like linguistics, philosophy, semantic web, that help us better construct knowledge organization system, better use them, but still they exacerbate a little bit the inconsistency of the words we are using across the discipline. So even if you understand this need to keep separate the field and the framework that are used, we see that we already have existing systems that try to integrate and use them together, this knowledge organization system, without referring to the term used to designate them, to referring to the philosophy of construction, but still try to integrate them together. And this system was very useful for in the biomedical domain. This is a simple query on PubMed that shows the number of publications we have around the unified medical language system. That is an example of this type of system that try to integrate together this heterogeneous group of knowledge organization system. So we think that it's important to make this principle ontological analysis for KOS themselves, for their constituents, but also to try to understand the representational commitment. And for that, we try to not use a specific domain framework and try to have a practical way of assessing what is a knowledge organization system. That's the reason we decide to present it as using an ontology-based framework, as a no-WL ontology under two foundational ontologies that are BFO and IAO. So, how we present knowledge organization system as a meaningful category, we try to build KOS under IAO and present it as a representational artifact. And we decide to represent it as a representational artifact because KOS can be seen as information entities under IAO, and also because they are made by intelligent human and human in general, they can be considered as artifacts. And for us, it can be just designed as a representational artifact. What is also important is that KOS and also KOS constituent denote something. And this something is called referent for us. And this something is very important because it describes what we try to capture in a fictional or a real world when we are creating or using a specific knowledge organization system. Another part very important is the atomic form of the content of the knowledge in a knowledge organization system. We call it the representational artifact, and stating that a representational unit is a part of a representational artifact, both being an information entity that need to denote a specific reference. And how we present it in KOSonto, it's very simple. We present it under IAO information content entity. This is related to IAO concept of information content entity. And knowledge organization system are just subclass of representational artifact, and representational unit is described as a subclass of information content entity. Now, when we know what is KOS and what is its content as a representational unit, we can think about what they try to denote, what is a reference they try to denote. And for that, we start by stating that because everything can be a reference, and KOS themselves can be a reference, everything in the world can be a reference, it's difficult to have reference as an ontological category. So we did not represent reference in ontology, in our ontology, but we describe the different subcategory of reference we can have. And for that, we have three subtypes. We start by type themselves and particular that can be found in other foundational ontology like GFO, UFO, and other. And particular particular being concrete in space and time, and type being what we commonly refer as concept. At first, we start to describe class as a subclass of type, but after discussion, we see that class is very important for knowledge organization systems. And even if they do not represent the type themselves, but they just try to extend something. And if I try to represent a disease in a knowledge organization system, it's not the type of disease I represent, but the class I'm creating is just an extension of the notion of disease that is outside of our knowledge organization system. That's the reason we grant class as sibling of type in particular, and describe it as always having some member, because we do not want to create some class of classes. This is something we do not want to discuss further. And also by being extension of all the subtype of type entities we can have: cognitive type, type by intention, Aristotelian, universal, and type by extension. And this subtype of type is not exhaustive. Just for our framework and for our biomedical domain, we only discuss this subtype, but maybe in other work, we can give an extension of this type. So how this is represented in KOSonto, we just describe class as equivalent to something that extend type and that always have a particular member. Particular is described as under BFO as equivalent to continuant and occurrent, and type can have instance for the Aristotelian one, and can be extended by class that have some members. And our representational unit that need to denote these referents can be represented. And for us, it was very difficult to state what is an atomic representation of a specific reference in a knowledge organization system. That's the reason we try to create 3 levels of representational unit. The first level is the purple one. And for the purple one, we can just have a specific ID or just a term to describe a knowledge organization, a referent, sorry. And most of the time, we have a specific ID and a term that is the preferred label. For the blue level, we can have additional terms to describe our representational unit. This term can be synonym, elliptic synonym, or just entry term. And beside all of these, we can have definition, description, and exemplification. We also decide to grant definition, description, or exemplification, describe these category as a purple level, because sometimes, and because of post coordination and also GCI, we can have, for example, in all, we can just have the information about a specific referent, not as a unique ID with a term, but just as a combination, as an axiom. That's the reason we state that this can also be the only way of assessing a specific referent. That's the reason it can also be considered as a purple level, the first one. And these different type of representational units are described in KOSonto as equivalent to an information content entity that has proper parts, some literal that play the role of identifier, but also have literal that play the role of preferred label. And because of the definition that can also be a representational unit, you say that we can also be a all double L class expression that cannot have a representational unit as proper part, and is also part of a knowledge organization system. We have also explained a representational unit, and that's considered as a representational unit that can have an explanation or a definition of exemplification. And formal representational units are representational units that can have an axiom to describe it. And when we have that, you see that we have different role of all the parts of representational unit. They can play the role of definiendum and definiens. We have role of identifier. We have different role for the term used to describe the representational unit. And also, we have also role for the composite textual representational used to make the definition, the description of the exemplification. After that, we try to apply it, this model to see how we can describe well-known knowledge organization system using our framework. And for that, we apply it first to ICD-10. And when applied, we can just describe ICD-10 as a tree-shaped is narrowed down hierarchy, and describe all the representational units of ICD-10 as disjoint, and also stating that ICD-10 representational unit level are mainly elliptic synonym, play an elliptic synonym role, and they also have textual composite representation as definition, exemplification, and also other things. ICD-10 representational units can have different referents, mainly some Aristotelian universals, for example, Benny of Neoplast or Flip. But sometimes we can have cognitive type. There is not a lot of them, but we can find them on ICD-10, like glaucoma suspect. And what is important is, like, when we read the exemplification or description of ICD-10 code, we can see that we have type relation of exclusion on what they try to refer to. And when used, it's difficult to say that if ICD-10 representational unit refer to disease, a symptom, or diagnosis, something our model cannot for now assess. When applied to SNOMED CT, we can state simply that for the structure, SNOMED CT is a hierarchy of classes, and all the representational units in SNOMED CT are formal representational units. And because SNOMED CT can represent some referent using post-coordination, we say that we can have composite representational units as in SNOMED CT, and the label of the representational unit can play the role of synonyms and fully specified name playing the role of preferred term. And we have not a lot, but we can have some of textual composite representation for definition of representational unit in SNOMED CT. And they mainly extend Aristotelian universal, but also sometimes some type by intention for some SNOMED CT concepts. Also try to describe mesh using this framework, and mesh can be seen as a tree shape is narrowed down hierarchy, not formal as ICD-10. And mesh can have different ID for the same term for different tree, and they also have a tree independent ID that can be seen as an eponym, and also the other term and anti-term can be seen as the eponym. And they also have a lot of textual composite representation, and because they only target topics in biomedical publication, is mainly some cognitive type that are referenced in mesh. Our last example is the HL7 appointment resource code. Is a flat list of 7 terms without any ID, and they have some textual composite representation as definition. They mainly refer to Aristotelian universal, but it's just a list of terms. In conclusion, we can see that our model can describe a different type of knowledge organization system and try to describe their content and assess what they have as reference. And it was the first strictly ontology-based attempt to have this ontological principle account of knowledge organization system. And we try to cover the most diverse type of we can have in the biomedical domain under a unique framework. We can think about different way of reusing it and describing knowledge organization system. For example, try to describe formal knowledge organization system as knowledge organization system that have formal representational unit. And for future work, we think about this notion of targeted referent, because we discussed the referent of representational units in knowledge organization system only, but sometimes the way these concepts are used in practice can change the reference for this ID used in biomedical data. For example, if I use an ICD-10 code, I don't necessarily think about the disease. It's just a diagnosis. I try. It's just a supposition, and sometimes it's difficult to see how this code can change in the biomedical data. But will be future work. So thank you very much for your time, and I'm here to take your questions.